Hello, welcome digital ship friends. Today we are hosting online vessel performance forum discussing how to connect shipping industry goals with digital technology. And today we will explore ways that digital technology can do more to connect with people's decision making during two 1-hour sessions with 1 hour break in between. And you are in the first session, and we will explore how to build energy efficient habits with data with our two excellent speakers, Christos Papandreou, Energy Efficiency and Fleet Performance Engineer at Athenian Sea Carriers, and Risto Kariranta, Shipping Performance Manager at Neste. Carl Jeffrey, founding editor of Digital Ship, is moderating, and without further ado, I'm inviting him to tell us some context into today's topic.
Okay, so the theme today is filling the gap between gathering data and making decisions in vessel performance. So the reason we picked this theme is that a lot of the discussions we've had so far have been about the challenges of getting data and analysing it, but there's a lot of further steps we need to take from the point where we've got the right data about ship performance on our screens to the point where the relevant people are making the right decisions, and there can be lots of different people involved. So we've got interesting perspectives today from a tanker operator and a tanker charterer. First, we'll hear from Christos Papandreou from Athenian Sea Carriers. He's going to talk about how to get the right communication between the participants, install energy efficiency culture and positive habits, and ways. So we've got sophisticated computer systems to predict performance, but how we use them is another question. Christos is a naval architect and marine engineer experienced in fleet performance monitoring and data science, and he created the energy management system at Athenian Sea Carriers. Athenian is a tanker management company in Athens with 5 vessels in its fleet. Then we're going to go to Helsinki, Finland, and we'll hear from Risto Kariranta, the shipping performance manager for fleet operations with Neste. So he's got a different perspective as a charterer, but also plenty of complex decisions to make. They want to track each cargo parcel's greenhouse gas footprint, and they want to use data gathered from ports and find better ways to execute the voyages overall. So Risto is a naval architect and master mariner with software business and data analyst skills, and an expert in ship and holistic fleet performance and logistics optimization. He's been working for the past 2 years at Neste, but he's also available for consulting work in shipping companies. And you'll see we've got speakers at pretty much the extreme north and south in Europe, but they've got a lot in common. There's not many naval architects in the world who are also specialists in data science and ship performance. So we're going to have 2 talks, about 15, 20 minutes each, first from Christos and then from Risto, and you can enter questions at any time. We'll take all the questions orally at the end, but the speakers might be able to answer questions by typing in. So there should be a lot of time for answering questions at the end. And just to remind you, in case we lose you part of the way through, we've got another session at 11 o'clock today with Minerva Marine and CMA, CGM. There's a different link to connect to that one. It says session 2. In case you aren't registered, I'll put the link to register into the chat box. But I'd like to invite Christos to give his talk. Thank you.
Hello to everyone. I hope you can see my screen right now.
Says yes. Yeah.
Perfect. So, hello to everyone and thank you for being here. My name is Christos Papandreou and I'm a naval architect and marine engineer. I work on fleet performance and energy efficiency, and I would like you to present today the topic of harnessing the potential of fleet data to promote energy efficiency habits. Firstly, I would like to tackle the effects of vessel fouling. As we are all aware, marine fouling is the accumulation of micro and macroorganisms on immersed phases, and generally fouling is mostly built up when the vessel remains idle. Moreover, marine fouling generates surface roughness and drag resistance, with increased drag resistance of the ship moving through water, resulting in increased fuel consumption and emissions, which may have regulation implications with the latest developments in IMO. Most importantly, marine fouling increases operational costs and environmental footprint due to the drop in performance. With regard to that, a typical example is that even slime films can lead to 20% increases in resistance and powering, while heavy calcareous data may result in power penalties of more than 85%. Having said all that about fouling, let's discuss the fact that vessels are very power hungry. The point which is not familiar with vessel data, this number can appear immense, as large vessels can burn up to 100 tons of fuel daily for propulsion and auxiliary engines. a number almost incomprehensible next to we use in our daily life. And these consumptions keep increasing for almost as long as the shipping industry exists due to the high demand of sea transport. The reason for which I underline these facts is that inside that framework, there is a false rationale that it's okay to bear, for example, 1 or 2 tons per day more. There is no significant difference in terms of percent. And this rationale starts to emerge. This is where energy efficiency starts to vanish because as individuals, we would never consume 1 or 2 tons daily to any kind of activity. So adopting that attitude may cost much. How much? Almost 30 billion US dollars per year. According to the foul control marketing of manager of Hempel, who cited figures from DNVGL based on data from Clean Shipping Coalitions back in 2015, he estimated the figure that much, as high as 30 billion US dollars per year. So, in continuation to all these losses, in terms of consumption and cost, energy efficiency by performance is an omnipresent topic which relates to shipping. Many have identified its benefits and have started many years ago to utilize its potential. However, the vast majority of shipping companies are still in very early stages and much still can be done. Some of the benefits of energy efficiency and performance include, but are not limited to the reduced daily costs, operational optimization, example, charter party compliance, data-driven decision-making, which in conjunction with human expertise can produce outstanding results, future-proof operation of our business, which can establish companies in the market and make them more competitive, and generally contributing to decarbonization. Delving more into the decarbonization, we can clearly discern recently a turning point regarding data and efficiency. Before EU MRV regulations generally issued suggestions to observe energy efficiency, for example, the SEMP, but none of them was mandatory. From EU MRV, which entered into force in 2015 and onwards, legislation addressed the energy efficiency and performance of the vessels with many regulations, such as EU MRV, UK MRV, IMO DCS, Sulfur Cap 2020, China MSA, etc. Up until now, the main target of all the above regulations is the official implementation of a procedure for data and fuel monitoring. The benefit on this includes reducing uncontrolled emissions, but also setting a basis for more stringent regulations such as the CII. If the IMO and generally the shipping industry manages to apply this regulation correctly, which unfortunately is a very long way ahead of us, this can be a game changer. I'm not going to delve deeper into how this can be achieved, but just the demand from the shipping companies for other kind of fuels is an excellent beginning. As already mentioned, data is the key. Without data, energy efficiency and performance monitoring can become an impossible task. Extensive care should be given to the raw data and sensors, as no good model exists which is fed with bad data. As they say, if you take care of your data, they are going to take care of you. Hence, a robust procedure must be implemented for filtering and validation, so as to get rid of bad data. The key for this procedure is human experience and must be efficiently utilized. Trial and error can greatly help. Last but not least, high-frequency data are essential to produce fast and reliable results compared to low-frequency data, which needs much more time to be converted in robust insights and may have hidden temporal effects. However, even low-frequency data, such as non-reports, in many cases work just fine and can produce reliable results, of course, in wider time intervals. So in order to harness the potential of fleet data, we need to use fleet performance to turn them into valuable insights. Fleet performance can be distinguished into two different approaches. The classic approach, which uses all tools which performance companies and engineers used up until recent years. There are many classic methodologies such as spoke trends, light running margin, and many more, but the most prominent is the ISO 19030 with model tests and sea trials. We have to admit that the ISO 19030, for example, is well built over the course of the years, provides viable, clear, and transparent results, is a robust procedure which can yield insights for almost any kind of company situation, and has worked and trusted by all performance engineering companies since a long time ago. On the other hand, the modern approach utilizes big data and machine learning methodologies which are aiming towards the holy grail of vessel performance. This approach mostly took place due to the fact that increased computation power nowadays caused the rise of such algorithms to prominence and establish them into such kind of problems. They can provide advanced analytics which can assess a large number of variables and find correlation between them. Also, if they are built correctly and deployed, they feature easy automation and high value. Of course, they're very suitable for route and weather optimization as well. In continuation to the modern AI approach, machine learning can be of great use in creating models to predict vessel performance. There are many state-of-the-art machine learning algorithms like neural networks, which mimic somehow the way that human brain works, or XGBoost, which is a technique that encompasses multiple classification and regression trees, and many more. Great increase of computational power gave these algorithms great potential for predictive applications. However, there's a conviction that nowadays everything is easy with these kinds of technology, and everyone is throwing data and taking results. We should always keep in mind that just dumping data and magically waiting for results is not going to work. There must be a robust methodology which will be thoroughly tested. And with that, we conclude that human experience is the key and absolutely essential. The variables have to be carefully engineered so as to enable the model to use its full capacity in understanding the problem and produce real value. Now, let's assume that we have built a good machine learning model so as to be utilized for forecasting. In order to be successful, it must have the following features. Firstly, the testing of machine learning models must be in line with real-life targets. In other words, the model must predict what the companies need and not just standard dimensionless KPIs. Secondly, the machine learning models must be always compliant with the laws of physics. If they defy them, they cannot be utilized. There have been cases where a model, let's say, has exceptional results in terms of standard error metrics, such as RMSE or root mean square error, but the consumption was decreasing with increasing speed. It is evident that this kind of models must be discarded no matter what. And thirdly, the voyage prediction provides a big picture. There is no need to say that even if a model manages to accurately predict the consumption for the next hour, it does not provide real value if it cannot predict the more distant future. Therefore, such models cannot be actually utilized for weather and route optimization, which of course is an area that can have real savings. Putting to the test the discussed items, we move on to a real-life example. In this graph, we can discern the performance of a vessel through time in terms of speed loss. We can also discern the two hull cleanings which were conducted. There were two hull cleanings due to the tight schedule of the vessel. All calculations strictly follow ISO 19030, which is proven to be very insightful. More specifically, the ISO correctly and immediately triggered the hull cleaning effect and the hull cleaning generally after an extended idle period. I will not delve deeper into the details, but the aftermath of the hull clinics testified daily savings up to, I believe, 10,000 US dollars per day. Just a moment, it's stuck. Okay, moving to a second real-life example, we can see the cumulative fouling of another vessel over time. This vessel also received two hull cleanings. The first one to the vertical sides and the second one to the flat bottom about, I think, 40 days later. A machine learning model predicted the fouling of the vessel with regards to many parameters like idle days, time from last dry dock, time from last cleaning, seawater temperature, distance from shore, depth of the seabed, among others. The first hull cleaning was part of the training of the model, which was afterward tested on the second one, the blue line. And it should be noted that the actual results were very close to the predicted ones. And this is the proof that this kind of machine learning models have great potential and can be widely utilized into such advanced prediction problems. So, the discussed technologies that we said are one thing. However, breaking the existing barriers and investing in them, both in terms of money and work hours, is another. Changing the existing cultural mindset can be an arduous task, especially in an industry in which there is a digital divide between the people who are accustomed to using emerging technologies and those who are reluctant to change. Typical example, let's say, are the traditional ship owners who are market-oriented, and the reactions depend on freight earnings. Therefore, it's nearly impossible to convince them to invest, for example, in high-end defouling advanced paints when the freight market is low, no matter what the return on investment is. That being said, a need for continuous validation emerges. The developed complex models need to be secularized and explained in plain words to the management, due to the fact that these people are the only ones who can take action to invest in energy efficiency. Should that not happen, and the explanation phase goes wrong, the management will neglect to consider options such as propulsion, improved devising, high quality defouling paints, etc. But most importantly, they will neglect caring about the everyday fleet and vessel performance. So in order to establish an internal culture of energy efficiency in shipping organization, the benefit must be made clear and transparent throughout a lasting time interval. Naturally, this is not an easy task. It should start by building trust in the procedure and the models by constantly validating their accuracy. This can be achieved through numerous ways, such as research, experiments, predictions, comparison across the fleet, and special across sister vessels, etc. But always keep in mind that all processes must also include a strong financial incentive so as to maintain the interest among stakeholders, again with continuous validation. Moving to the next part, the next critical role towards achieving energy efficiency in shipping is inevitably played by the vessel. Without the crew support, all these actions are lost in vain. An indifferent crew will not, for instance, stop the purifiers, decrease the jacket temperature, isolate the fuel tanks from heating, or alter the boiler start-stop pressure thresholds when the vessel remains idle to diminish fuel consumption, always under certain circumstances. Building an energy efficiency culture among the crew is a laborious job, as most of the time actions oriented toward energy efficiency will be perceived by them as actions that are contradicting with safety and are more workload, both greatly disliked by the crew. The only settlement on this conundrum lies in the cultivation of this culture by providing constant guidance and explanation to the crew, along with seminars and workshops on the matter. Therefore, the crew must be a supporter of the process, and the head office should help the crew by generally reducing their workload when possible. Two prominent examples towards that end are route optimization and rearranges. In the first case, the update of the passage plan every time there is an update on the route adds work to the crew. In the latter case, the safety margins when each chief engineer is going to start the second generator is very subjective and can have impact on fuel burn. The above examples are common in shipping industries and can certainly enhance energy efficiency, but frequently remain untouched. The office should collaborate with the crew to solve this kind of issues and convince them to adopt this mindset, resulting in gradual inculcation and ultimately the establishment of an internal culture focused on energy efficiency. There is a need to ensure all discussed plans must be robustly implemented and go beyond mere compliance, as people tend to follow routines. It is up to our collective will and hard work to transform this inclination from thought to allow and create energy efficiency habits. So in order to conclude, the key takeaways are summarized as follows. Data is the key. Intelligent usage of them can lead to excellent decision-making process. With the advent of new AI technologies, a new tool for fleet performance has been acquired. Continuous validation and human expertise are absolutely essential for creation of robust energy efficiency procedures. In order to achieve the race towards decarbonization, the cooperation of departments within shipping companies and generally between the stakeholders is a prerequisite, and or else all efforts will end up being, let's say, a screen product. Also, without crew support in this race, most of our actions are lost in vain. And finally, real-life examples are the living proof that all these actions have indeed positive effects towards decarbonization, and we need to follow. With these thoughts, I would like to sincerely thank you and gladly ask any questions.
Wow.
So back to you, Carl.
Well, that's great. Thank you very much. And that's enormous bandwidth you covered there from the digital technology side and the people side. So we can take questions at the end, I think, but we'll go now to Helsinki, and we're going to hear from Risto Kariranta, who's the shipping performance manager for fleet operations with Neste, who's going to give a talk. So I'd like to welcome Risto. Cheers.
Thank you. Thank you very much. I'll shoot from here. Sorry. So what I would like to discuss today is a couple practical example of utilizing data to harness benefit for shipping. And as Carl mentioned, can you hear me?
Yep.
Hello?
Yep, we can hear you fine. Yep, that's great.
Okay, good. Yeah, so a couple practical examples how to utilize the data to harness benefit for shipping. So what I would like to discuss to you first is what are we working with emission data. And first of all, okay, the motivation. We want to first of all wanted to start to gather the emission data for several purposes. Of course, the regulatory landscape is changing, and we expect that we need to have better transparency on the emissions, so that we can we get the support we need for fulfilling the requirements for the regulatory landscape. And there naturally the driving factors are IMO. We have a EEXI regulation coming up, carbon intensity indicator, and then from EU side we expect to have shipping included to the emission trading system. And furthermore, starting 2025, Fuel EU Maritime, that is regulating the carbon intensity of the energy used on board. But the regulatory things are not the only reason why we are working on this. We have also customers that are interested on seeing the full greenhouse gas footprint for the transportation as well. So they want to see the full footprint of the product they are purchasing. And furthermore, as Neste is the leading provider of renewable biofuels in the world, so in that kind of business, also the carbon footprint of the transportation is or does have a effect on the price that we get from the product, or on certain regions. And the third reason is our internal target. So Neste has clearly said that, okay, scope 3, meaning the indirect emissions or actions for getting the feedstock and products to the customers, is part of our whole company reduction targets. And how do we do this? We first of all, okay, we have our fleet is consisting on roughly said it's the time chartered fleet and a lot of spot voyages. And for the time chartered fleet, we are purchasing the fuel, so we definitely know how much fuel is being burned on board the vessel, and it's relatively straightforward to convert that to emissions. And for the spot vessel, of course it's not that straightforward. The ship owners do not disclose us the fuel consumption, at least at this point, in a very consistent way. So we are using estimation. So we are actually using a third-party company to basically calculate the estimated emissions for the spot voyages we are using, or voyage charter voyages, and then allocating the estimated emissions based on the estimation we have for our cargo share of the whole voyage. But we, of course, we wish that in the future we would also start to receive reported emissions from our shipping suppliers. So how does it look like? Okay, we crunch the numbers in the back end, and what I wanted to show to you is the detail level calculation. So we have here, for each and every parcel, we have calculated the allocated fuel consumption and how that is divided per ton mile, per tons of cargo, tons per nautical mile, and total emissions. So for each and every cargo parcel we are transporting, we have these calculations in our reporting system. And what do we do with this? Okay, we have set targets for our shipping activities. We have set a baseline based on our recent activities from 2019 to 2021, and a certain reduction factor that we expect to have yearly. And then every time we have a voyage completed with our cargo, we put the numbers into our backend and get the result at where we are today. And for example, here we can see that the grams per ton mile value compared to this baseline is now 10.65 grams per ton mile, and that's 3% below, a little bit more than 3% below the baseline we have set. And these numbers could also be utilized as a kind of emission budget. So this is something that in the future could be utilized, so that if we get the total emission target for our activities, then we basically say to our persons in charge of chartering vessels that and arranging the transportation, that okay, this month you have for example 3,000 tons of carbon dioxide allowance, and then if you exceed that amount, then you have to do some measures which typically are more costly than the cheapest transportation available. And the second, the middle graph here represents that kind of approach, that we have calculated the baseline for the end of the year, and then we are monitoring constantly that where we are on that. So for example, in February we were a little bit below the target level, and March is not completed yet, so that's why it's showing quite a lot less than target. So how do we impact on the emissions? Okay, we as an industrial charter, we have maybe, I would say we have maybe a little bit less means to affect to the technical performance of the ship, like the previous speaker was describing for the hull cleanings and so on. But for us, the tools are, first of all, okay, considering the ship that we are chartering in, if we have a possibility to charter in more energy efficient vessel. The second measure we have is considering the speed. There we have quite a lot of saying. We can adjust the speed of the time chartered vessels quite easily if we see that that's plausible. And secondly, we can of course maybe discuss a little bit about the delivery windows and so forth, so that we could maybe maybe in some occasions slow down the vessels a bit, even in voyage charter. Then the third measure here mentioned is considering the fuel. It's something that is coming up, but it's not very active yet. But soon there will be low carbon solutions also for marine fuel available, and then we have to consider taking those into use. And definitely there are new development will be starting that we could estimate the cost of the carbon intensity reduction for each fuel bunkered with a lower carbon intensity than a traditional fossil fuels. But the big picture is really important. So for us as a charterer, quite a lot of impact can be done by considering the overall efficiency, and that means combining the cargo parcels in a smart way and keeping the fill rate of the vessels in a high level, and considering the load ports and delivery ports, so that can we combine certain parcels with bigger vessels. That clearly has an impact on the carbon dioxide emissions. Okay, the second example I had here is utilizing the port availability data, and here what I'm showing to you, what you see here is the port plan or jetty plan for our refinery terminal. So a lot of vessels coming in, and also you see there the plans for jetty use. The numbered boxes here are kind of a jetty blocks, and as everybody here knows, that the plans for utilizing the jetties in port, it's not stable, and there is a lot of changes based on certain unexpected circumstances. And how we are utilizing this is that, okay, we are extracting the data from our refinery berth planning system, and once they update the plan, when they know that there is some changes happening, we immediately send information to the vessel that is arriving, especially for the time chartered vessels. Okay, your jetty timing has changed. New ETA is this and this, or it's not ETA, but the kind of recommended time of arrival, and include also the calculation about how much fuel and carbon dioxide could be saved if they adjust the ETA based on the new information, and then typically the vessel adjusts the speed accordingly. And what do you get out of that? This is our last year results with this kind of system for our forward terminal. So we save quite a lot of fuel money. Also, we reduce the anchorage hours, which is good. Our anchorage area in our forward terminal is quite crowded, and therefore we also calculate the savings based on that. And so, for example, last year, even each of these slowdowns, it's maybe 1 ton of fuel or 3 tons of fuel very typically when we have this kind of information. But when those start to accumulate, we end up here. So last year we exceeded already 1.2 million in savings with this very simple approach, and about 7,000 tons in carbon dioxide. So very good tool, and naturally we are expecting to expand this to other ports. naturally this is much easier with our own terminal, but we have found some cooperation partners, for example in Antwerp, that is helping us to get this similar type of availability data from there, and we plan to utilize that in the future more, and naturally on as many ports our vessels are calling. Then the third example I had is about data-driven holistic planning, and with this example I would like to kind of show how quite different types of data set can be combined to a holistic planning system. So the first example here is that, okay, we have been gathering statistics about our vessel port calls, how much time they are spending on the port, how much cargo they had. So we have a long history of each and every vessel we have in our fleet about how much time they spend on port. And what have we done with this data is that we have created the model so that based on the planned cargo amount and the cargo operation and the terminal and the vessel name, we can predict how long the vessel will stay in the port, in the next port. And okay, it's a prediction, so it's naturally it's not 100% accurate, but it's really good for planning purposes. I will come back to that, how that's utilized. The second thing is a traditional performance analysis. We have performance models of our own fleet, the time chartered vessels and so forth, how much fuel they are consuming in different conditions, and that can be utilized for predicting the fuel consumption for the coming voyages. And what do we take out of this? We have our system for planning the system traffic, so we have all the possible cargo parcels in the system and the fleet that is mainly handling the transportation, and then all the destination and cargo parcels and so forth here in the plan. And this data that I showed you earlier, then for example, we have calculated with a system that is calculating the voyage cost based on the weather conditions and this vessel performance model, how much fuel we expect the vessel to burn during this voyage and how long this voyage will be. And then secondly, using this port time prediction model for defining that how long time we need to reserve for the port call. And then what do we take out of this? Okay, we calculate the whole system traffic cost and can create different scenarios about how this transportation need could be fulfilled and get the cost estimation. So we also add the port cost estimation to this whole setup, and then can create different scenarios and quickly adjust the plan if some unexpected circumstances will happen. And this is something that manually this kind of comparison work would be extremely laborious, but utilizing these data models and prediction models, it gives you an instant feedback that okay, how good is the overall plan. So maybe the conclusion from this is that okay, we have awful lot of data about our activities, and I think we are only in the beginning of thinking how we can utilize it. We have already found out some ways to utilize that, and it's giving us tangible results. So definitely, when somebody's saying that shipping data is just a buzzword. I disagree strongly. We have awful lot of use cases that prove that the data has value in shipping operations. I think both for the ship owners and charterers. Thanks. Back to you.
Wow, thank you very much, Risto. Well, I think that's enormously amazing perspectives we've got from a tanker operator and from a charterer. I was thinking this is maybe a vision of the future, because this stuff is going to get more and more complicated, and we're only just seeing how complicated it is. I'll just invite Christos, if you want to turn your camera and microphone on, and if anybody wants to ask some questions, I've got a few there already. I noticed there's two questions about the data quality, which I think this always comes round as the most difficult problem that companies are having. I mean, we weren't really talking about data quality, we were talking about what to do with the data, but I don't know if you both like to share your own perspectives on data quality. I don't know if it's a question you can answer sort of quickly. It's such a big subject. We start with Christos, maybe? Do you want to?
Yeah, of course. So how I do validate the data and be sure that there is no garbage. This is a very generally difficult task, and you can answer it with one question or one answer or whatever. But generally, there are many validation rules, filtering. You have to filter out erroneous data. You have to make trends between data. For example, you can have a speed through water of 5 knots and a consumption of 100 tons. So there are many variables correlating to each other, which need to be validated and filtered and all this kind of stuff. You have to make continuous validations in terms of the previous ROB with the today consumptions and the flow meter values. Which is generally the easy part to create, and all these kind of checkings. And the most difficult part is to start cooperating with the crew, cooperating with the chief engineer, cooperating with the captain about the speeds, about the consumption, about the power, so as to be able to, let's say, to ensure that if the sensor tells a value, this is the correct value. So there are three kinds of, let's say, validations: data itself, between non-reports and the auto-log data, and between the office and the group in general.
Oh, Risto, do you want to share some thoughts on data quality?
Yeah, well, the data quality is naturally so always a kind of a headache for us that are utilizing the data. So I think what it needs is it's hard work. So we have to define that what are the sanity limits, and naturally we have to enforce processes that we get more accurate data if it's manually produced data, and then on the other hand, if it's a automated data collection, then we use certain alarm limits that, okay, if we expect that there are certain issues, we can then address this issue and try to fix that. But of course, it's takes some time, and we have to kind of take that into account, that we do not get always perfect data in our cases where we utilize this and treat that issue somehow like discarding part of the data, or then trying to fix that somehow. But yeah, it's for us, it's definitely a continuous issue, and I believe there is, in reality, we can never reach the level that we have absolutely correct data always, but we just need to learn to live with that and still get the benefit out of that.
Okay, so I'm very interested in this question from Luca Brugger. So LinkedIn says he's a fleet performance manager with Ridgebury Tankers in Connecticut. So he's got up very early to hear your talk. I think this is probably interesting for both of you. I mean, I was quite surprised, Risto, when you said you couldn't get data about vessels on spot charter, because I thought everybody was obliged to give all this data these days. It'd be quite interesting to hear what Christos thinks. But he's asking how you estimating consumptions of spot vessels. You mentioned you're using a service that's estimated. Do you want to say a little bit more about how you do that?
So this service that we are using, okay, I can mention the name. It's a company called Napa that is providing that. So what they have a performance model for each and every vessel in the world, and that's basically created based on well, firstly following the normal ship engineering principles, that how the speed and power will behave on a certain size of vessel, but they are utilizing their database from the actual operations of the vessels and adjusting those. So there is a data-driven modeling behind that. And of course, that's not 100% accurate, but it's indicative enough for us to start. And we have checked against the vessels where we know the fuel consumption, and the accuracy is okay. It's maybe within like 5-10% of the reality, and for that's enough for getting started. And about your comment that getting the data from the ship owners, it's not mandatory yet. So basically, it's not happening on a daily basis, but we have certain ways of enforcing that in the future. For example, there is a consortium called Sea Cargo Charter that is working on defining the principles of the emission data and how to share that between the ship owners and charters and so forth. But naturally, there is a lot of work, and there we have the issue that, for example, from the charter's point of view, we are using awful lot of shipping companies for helping us to transport our cargoes, and naturally each and every shipping company has slightly different reporting system, and then if we would start to get data from all of them, we should spend awful lot of effort for just treating the data from the different formats of the different ship owners. And there is one aspect that in the future, hopefully there would be some kind of brokers in between that could do that for us, so that we could get it easily to our systems as well. And naturally, for the ship owners perspective, it's vice versa. Each and every charter maybe in the future are asking the data in their format. So maybe we will have a shipping data brokers in the future that could help us on this matter.
Well, so Christos, you probably shouldn't talk about Athenian specifically, but maybe talk generally. I mean, are you finding oil companies are asking more and more about data and demanding it, and you're giving it to them? And is this a surprise that Risto can't get the data he's looking for, or what's your thoughts?
So about the question of generally consumption, emission, spot vessels, and all these.
Or giving data to charters as well, yeah.
Yeah, the data to give to the charters, of course, and for internal use. It's exactly one slide of my presentation, which is we have two kind of approaches: the modern and the classic. The classic is at least just how we do it, based on the speed loss and the ISO 1930. We use the speed loss in order to estimate the vessel consumptions for different speeds and etc. based on different time intervals and all this. And the modern approach, which we're trying to perfect for the moment, and to cross-check with the classic approach, is all this AI and the machine learning methodologies, which can be utilized for performance predictions and fuel consumption predictions. And we try to feed them with more and more parameters, but up to a point, so as to be as accurate and as computational efficiency, so as to be able to use it every day.
And there's also a question about whether a tanker operator chooses to give the data to charterers if it's not absolutely forced to. I mean, it sounds like, well, some companies would and some companies wouldn't. I don't know if you have any thoughts on
Depending
that.
on what you need to do, you know your vessels, you know what is capable of, if it's energy efficient or not, how is the rates, and it's very internal decision making in that how we are going to give the data or not, or up to what extent you are going to give. You know what the kind of offer you have, communication and negotiation on this, up to which speed, and all these kinds.
Well, that's very interesting. So another question here from Gavin Laidlaw, who's Chief Commercial Officer with Signal. So he's asking about they've seen that the bunker fuel varies quite a lot with different crews. So this is perhaps I think Christos, you kind of covered this in terms of getting the good habits and encouraging people. And I guess Risto, probably you've seen that your vessels have got some variability between them, and I don't know, maybe
Yeah.
should go.
I believe that this is another slide of our presentation. You know, this is a long-time job, a long-time collaboration and cooperation with the crew. Of course, in that area, you have the weather routing and the route optimization in general, because data play the major part in all this. Okay, together with our expertise, together with captain's expertise, some weather route optimization models cannot know some things that captains know. Some risks that captains are aware due to their expertise. And all companies, performance companies and engineers try to take this expertise and implement in this kind of models, but in order to reach the captain's expertise, there's a long time ahead of us. However, in order to answer the question, you have to speak, daily speak with the chief, daily speak with the captain in order to change some habits. For example, let's say the subjective threshold limit for the second diesel engine generator. Because some chief engineers may want to use them all the time for let's say safety, for the safety of a blackout, but this may have fuel implications, and the whole thing is that you have to make workshop with the crew, seminar with the crew, daily cooperation with the crew to convince them and find the most efficient way into working with them, and at the same time having the least consumption for the vessel.
Yeah, I see it must be annoying for crew if you've got somebody calling from halfway around the world saying, according to our system, you're using your generator far too much, and you've got they're thinking you've got no idea, and I suppose these issues you do have the whole time, isn't it?
Of course, the crew has the first word on that. You can't go and drive the ship for the captain. Okay, but the collaboration makes that that energy efficiency better.
Yeah, Risto, do you want to share your thoughts? So if you see like similar vessels, but
yeah, sure. So of course, from the charter perspective, the question is slightly different, and well, first of all, for the void charter vessels, we have the kind of mutual goal with the ship owners that definitely want to operate the vessel with as energy efficiently as possible, because it's definitely benefiting them as well. For the time charter, it requires from us a lot of work and monitoring, and definitely communication. So it's from charter's perspective, it's not maybe the right way to communicate with the vessel directly about certain things, but we definitely monitor what is happening with our time chartered vessels and have communication with the ship owners about the performance, and discuss very much about how the vessels are doing and what could maybe be improved. Sometimes we even do kind of a mutual project for energy saving devices and so forth. So yeah, I think it's all about teamwork and getting these kind of goals through. It means that okay, you have to work quite a lot with the data and understand what it means and how it could be impacted, and then of course, luckily the shipping companies have a lot of people that understand what we are talking about, and then can basically then impact the vessels in their fleet. So this definitely is progressing in a good direction.
Well, that's very good. Well, we've got about 5 minutes left. We've got one last question from Dionysis Asimakopoulos, who's a growth manager with Kongsberg Digital in Athens. He's saying about data silos and complexity. I mean, that was a thought I had when I saw your talk, Risto. This stuff is enormously complicated, but you must understand it all yourself. I guess that's the first place to being able to manage it. I guess the same for you, Christos. I don't know if you'd both like to take a couple of minutes. I mean, how do you make this stuff manageable when it gets so complicated so easily?
Well, I believe that I can take the lead. Okay, Risto, go on.
Yeah. Okay. Well, maybe I start. So definitely, it's sometimes it's a hideous work. It's behind barriers or not behind barriers. It's when it's gathered on for different purposes. It's not compatible easily, and how we are doing that. We have a kind of a dedicated team working on those issues. So I would say also that okay, it's hard work. It's not very easy to automate all of that, but step by step you learn how your own data, where it's coming, how it's formulated, and how to combine that with each of the sources, and then once you have that, then the kind of sky opens, and we have unlimited possibilities to learn from the data and find new ways to operate our fleet better.
Oh, Christos?
Yeah, moving to the tanker company perspective, I believe that there is a need to have a dedicated person or department into all this. And generally, you need to have a great cooperation between departments because there is a caveat, a pitfall where when shipping companies wants to invest into energy efficiency performance, and they say, okay, we'll take that company and this data from from different vendors and providers, and do not have a dedicated person. They say to let's say superintendent, okay, deal with that or deal with the regulations. Which that person does not have the time. Does not have the time to start to doing things, to have data science, skills, and start collaborating with each and any one of the departments of the company to implement procedures into all that. So I believe that you have to have a dedicated person or department, depending on the size of the company, assess all the data together with the whole company and the other departments, and keep what you need. If something you have something, let's say a service or whatever you may have that you don't use, if you don't plan to use it, just leave it, let it go. That's from my perspective.
Oh, that's fantastic. Well, thank you very much, Risto and Christos. I think you've given us a vision of the future, and it may be more complicated than a lot of people thought. And thanks. So, just to the audience, I hope we'll see you again in an hour's time, where we're going to hear from Minerva and CMA CGM. I'll just put the link to register in the chat if you haven't registered already, and I shall pass back to Vida. Thank you.
Thank you.
On mute, I think.
Okay, here I am. So hopefully you and all of us will have a better understanding about how to develop energy efficient habits with data. Christo and Risto are two prominent experts with hands-on experience creating energy efficient culture in shipping. And as Carl invited you already, we look forward to see you at 11 a.m. Where we will discuss and explore the players in vessel performance and development of decision support tools. We'll see you after 1 hour. Take care.
Bye-bye.
Bye.
Thank you. Bye.
Bye, thank you. Bye.